Hi everyone. For this lesson I want to talk about just how to draw the unit circle. So first of all, I want you to remember that the points on the unit circle are what we're really concerned with. Those are the ones that give you values. Each point on the unit circle for the angle that it matches up with gives you first cosine, then sine for that angle. Now if you want to see why, I made a video called Deriving the Unit Circle, and you can watch that one. But basically, I broke this into 3 videos because it would have been just way too long for one. So part 1 is deriving. This is kind of like part 2, and then part 3 is going to be how to actually use the unit circle. So for today, we just want to focus on drawing it. So what we want to do is we really want to focus on the angles that we can do without a calculator. So the unit circle, yeah, every point gives you cosine and sine. But if you're trying to figure out sine of 72 degrees, the unit circle is not going to help you much with that because we don't know what that point on the unit circle is. So we want to focus on the ones we can figure out without a calculator. So we're going to remember, way back in Math 2, we learned about something called the special right triangles. And those were combinations of 30 or 45 degrees. There were 2 of them. There was a 45-45-90 and a 30-60-90. And because of that, those are the angles we focus on in the unit circle because those are the ones we can do without a calculator. All right, so let's talk about how we're going to draw all the angles on a unit circle and label them correctly in both degrees and radians. The first thing you want to do is what I already have on the projector here, or on the screen here. You want to draw a circle in a coordinate plane. Now remember that the unit circle is a circle with radius 1, and that's actually what we're looking at right now. Now, the coordinate plane itself, the axes, give you some of the angles. They give you what we call quadrant angles, and in degrees it would be every 90, and in radians it would be every pi over 2. So let's label those. Let's label what we have so far. So in degrees, this is 0. 0 always starts, that's 0 degrees. Always directly to the right is 0. And if I start going around counterclockwise, the top would be 90. Over here would be 180. The bottom would be 270. And then the end of the unit circle would be 360. So 360 and 0 are the same. The unit circle ends where it begins after one full rotation, which would be 360 degrees. Now in radians, what it is every pi over 2. So what I'm going to do, every time I do radians, just to kind of, I think it helps you visualize the angles, I'm going to mark them unreduced and then go back after and reduce them. So basically what we have in radians, 0 is 0. So it doesn't matter if you're measuring radians or degrees, it's always 0 at the beginning. And then each quadrant angle is a pi over 2. So this would be 1 pi over 2. This would be 2 pi over 2. This would be 3 pi over 2. And this would be 4 pi over 2. Now 1 pi over 2, I'm going to take the 1 out and just call it pi over 2. Now 2 pi over 2, the 2's cancel, that's just pi. 3 pi over 2 doesn't reduce, we'll leave it. And then 4 pi over 2, 4 divided by 2 is 2. So 4 pi divided by 2 is 2 pi. So there's our quadrant angles in both degrees and radians. Now the next thing I like to do, I don't like to do it all in a row because that can be a little confusing. I do all the 30s next. So what I'm going to do next is I'm going to take take each quadrant, and as best as I can, I'm going to try and split it into 3 equal pieces. Not that great. So it's a little bit hard for me on my computer, but you guys get the picture. Imagine me splitting each quadrant into 3 equal pieces. Ends up looking kind of like a beach ball. Okay, those blue lines, including the quadrant angles also, give you the 30 degrees. So let's do both degrees and radians. Degrees are always easier for these. So starting at 0, I'm just going to add 30 each time. It's 30, 60, we already have 90, 120, 150, we already have 180, 210, 240, we have 270, 300, 330, and we have 360. Now in radians, I'm going to do the same thing where I'm going to count pi over 6s. I'm going to not reduce them first and go back and reduce them later, just to show you the pattern of what's happening here. So this is 1 pi over 6, 2 pi over 6. That one right there is 3 pi over 6. This is 4 pi over 6, 5 pi over 6. The pi itself is 6 pi over 6. I don't really have room, I'm going to leave it off. This is 7 pi over 6, 8 pi over 6. That one right there is 9 pi over 6. This is 10 pi over 6. This is 11 pi over 6. And the 2 pi is 12 pi over 6. I don't really have room on the edges for those. But let's go through and reduce each one. So 1 pi over 6, let's just get rid of the 1 and call it pi over 6. Now 2 pi over 6 you can divide by 2. That would be pi over 3. 3 pi over 6 is pi over 2. We don't need any of that. Let's just get rid of the 3 pi over 6. 4 pi over 6 reduces by 2. Divide each of those by 2, you get 2 pi over 3. 5 pi over 6 doesn't reduce, you leave it. 6 pi over 6 was pi, I didn't even put it in there, but we would get rid of that one. 7 pi over 6 doesn't reduce. 8 pi over 6 you can divide by 2. So if you divide each of those by 2, you get 4 pi over 3. And for those of you who already know the unit circle, these numbers are probably starting to look very familiar. The 9 pi over 6, that's 3 pi over 2, we already have it, we'll get rid of it. The 10 pi over 6 we'll divide by 2 again. That gives us 5 pi over 3. And the 11 pi over 6 will leave, that doesn't reduce. And then the 12 pi over 6 was 2 pi, we would get rid of that one. So what you see is, now all of a sudden you see the familiar unit circle angles that you knew, but instead of just memorizing them and having to remember, okay, it goes pi over 6, and then pi over 4, and then pi over 3, and then pi and 2 pi, you know, all of a sudden you really understand them, you realize it's just multiples of pi over 6 that are reduced. Now we have one more piece, and it's the 45s, or the pi over 4s. So what I'm going to do, for my last step, I'm going to go through and split each quadrant exactly in half. And that's those red lines there. Now those, including the quadrant angles, give you the 45s, or the pi over 4s. So the first one, we'll start at 0. The first one is 45. The top is 90, we already have it. The next one would be 135. I'm adding 45 each time. The next one is 180. We have it. Here is 225. The bottom is 270. We have it. And then here is 315. And we're back to 360 again by adding 45 each time. Now the good news on the pi over 4s, you don't have to reduce any of them. Any of them that needed to be reduced were already reduced. So you start at 0. The first one is 1 pi over 4, or just pi over 4. The top is 2 pi over 4. We got that one already. This one here is 3 pi over 4. And then 4 pi over 4 is pi. We already have that one. This one is 5 pi over 4. The bottom is 6 pi over 4, which reduces to 3 pi over 2. We have it. And then this last one here is 7 pi over 4. So with the pi over 4s, the ones that need to be reduced are the quadrant angles, and you already have those. So all you have to do is odds. It's 1, 3, 5, 7 going around. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So if you break it apart in groups by that, like that, it really helps you realize what the angles are. You don't have to memorize, because I see a lot of people trying to memorize the angles, and they get like 5 pi over 3 and 11 pi over 6 switched. Or something like that. They get a couple angles mixed up here. They write the wrong thing. If you're really understanding what you're doing, you don't have to memorize anything. You can just look at it and know whether it's a multiple of 30 or a multiple of 45 and work from there. All right, so now that we understand the angles in both degrees and radians, see, that's the key to the unit circle. If I ask you a question about 7 pi over 6 radians and you don't know where that is on the unit circle, then you can't answer the question. So step 1 is to really understand all the angles in the unit circle in both degrees and radians. Now step 2, once you have that understanding, is to know the points. Because remember, right at the beginning today, we said it's the actual point on the unit circle that gives you your cosine value and your sine value. So in the unit circle, we talked about those special right triangles. Each group of 3 points in each quadrant is going to make one of those special right triangles. Now the 45s, the ones we did last, the pi over 4s or the 45s, those are the easiest ones because sine and cosine are both root 2 over 2. The 30, 60, 90s, you have to think for a second because they're different. What you end up with is a longer leg and a shorter leg. And the longer one is the radical 3 over 2, the shorter one is the 1/2. Okay, so here's a unit circle I found online that we're going to use to label some points. Mine was way too cluttered up with all the, I barely had room to write the angles on. We didn't have any room to write points. So here's a unit circle that has all the angles marked in degrees and radians on the inside of it. And it has a place for us to mark points on the outside. And what I'm going to do, instead of, and again, what you may have noticed is I'm not trying to focus on memorizing the unit circle. I'm trying to focus on helping you guys understand it so you can find the values without having to memorize it. If you memorize something, it works short term, but eventually you'll forget and it'll be gone. But if you understand it, you know it forever. So what we're going to do is we're going to visualize triangles to find our points. So let me pick one. Let's say I want to figure out what this point right here is. Now, in order to plot that point, remember this is an XY plane, this is a coordinate plane. So in order to plot that point, I went over this far and then up this far. This is my X value, this is my Y value. Now if you visualize that right triangle I just drew in green, it's not a 45, 45, 90, it's a 30, 60, 90. So you have a short leg and a long leg. Now you can see just by looking, the X is the longer one. So in this case, the X is going to be the longer one, radical 3 over 2. The Y is going to be the shorter one. That's 1/2. There's your point. Radical 3 over 2, comma 1/2. And we'll do a couple more. In fact, I'll do the whole first quadrant. Let's get rid of this. All right. Let's do this point next. If I imagine myself plotting that point, I went over this far and then up this far. That's a 45, 45, 90 triangle. That's the easy one. They're both the same. They're both radical 2 over 2. I don't even have to worry about it. Okay. Now, let's do this point. If I'm plotting that point, I went over this far and up this far. That's a 30, 60, 90. Remember, over is X, up is Y. This time the X is the shorter one and the Y is the longer one. So this time the X, the first one, has to be the 1/2 and the Y has to be radical 3 over 2. So now we're kind of understanding where these numbers come from. Instead of just memorizing, oh, this one is 1/2 comma root 3 over 2, and this one is that, and this one is that, we're understanding where those points come from. Now, I did the first quadrant, which is the easiest one because everything's positive. If you're in a different quadrant, it's the exact same thing. Just know your plus minus. Remember, we're just plotting points. This is X and Y. If I go up, Y is positive, down Y is negative. If I go to the right, X is positive, to the left, X is negative. So let's say I wanted to find this point right here. I'm not going to do the whole unit circle, but let's say I just wanted to find this point right here. To get to that point, to plot that point, I started at 0. I went this far to the left, and then this far up. Now remember, this is your X value, this is your Y value. X is definitely the longer one, so it's going to be the radical 3 over 2, but I went to the left instead of the right, so that's a negative radical 3 over 2. Now the y value is 1/2, and it's up, and up is positive for y. So my point here would be negative radical 3/2, comma, positive 1/2. And that works in any quadrant. So let's say, for example, I wanted to do this point right here, 300 degrees, or 5 pi over 3. To get to that point from the center, I went over here and down here. Here's my x, here's my y. Now x is definitely the shorter one, that's the 1/2, and this time x was to the right, so that's positive 1/2. Y is the longer one, that's the radical 3/2, but this time, since it was down, that's the negative one. And it's always x comma y, so this point is positive 1/2, negative radical 3/2. So this is a good way for you to find points on the unit circle without having to memorize them. I mean, it's good if you have the whole thing memorized, it's fine. But remember, if you memorize, you can forget. If you understand, you know it forever. So right now you guys are understanding the unit circle. And that's good, because I think that'll really, really help you guys in the long run. Okay, there's one last thing. They're actually already marked on this picture that I downloaded. But remember we talked about the quadrant angles? The quadrant angles are not triangles. The quadrant angles should be the easiest ones actually, but I probably see more mistakes on those than anything else because people get caught up with triangles and give the wrong answer. So don't forget, the very first thing we said about the unit circle is that the unit circle has a radius of 1. And if I'm asking you what point this is right here, it's not a triangle. It's just one space directly to the right. So if I'm saying, how did I get from the center to this point right here? I went 1 to the right and up 0. I didn't go up or down at all. So that's the point 1, 0. Or same thing, if I asked you guys, what is this point right here? That's not a triangle. It doesn't go to the right or left at all. It's just down 1. So that's the point 0, 1. I didn't go, there's no x value. I didn't go right or left at all. I just went down 1. So that's 0, negative 1. The top would be 0, positive 1. The left would be negative 1, 0. So just remember those quadrant angles really should be the easiest ones. It's always some combination of, they always have 1, 0, and the other number is either positive or negative 1. You got to figure out whether it's a positive or negative and the order of the 0 and the 1. All right, so that's how we draw our unit circle and how we know the points on it. In the next video, remember I separated because it would have been way too long. In the next video, we'll talk about how to use the unit circle.